So this is lesson 6.3 called Adding and Subtracting Rational Expressions. As you might guess by the name of the lesson, what we're going to be doing is adding and subtracting rational expressions. That's right. So I want to spend some time reviewing here, just adding and subtracting what we would call numerical fractions. And although it may not seem like a big deal, first let me rewrite this. And I've never had the opportunity of teaching this kind of idea to junior high or elementary students, which is probably where you first learn it. But I don't know what you've been told, but what I would tell those students if I had to teach that to them, and what I'm going to tell you, is do not think of this as 5 over 8. Do not think of it as 5/8, or sorry, do not think of it as 5 over 8, think of it as 5/8. You don't have to think of every fraction that way, but it helps to explain why what we're going to do works. This is 5/8, and we're adding 7/8, and we're subtracting 3/8. This is no different than me saying I'm going to take $5 and add $7 and subtract $3. The reason why I can do that, why I can take $5 and add $7 and take away $3, is because these things I'm adding or subtracting are the same types of things. This is what we call like terms. This gives us, by the way, $9, right? And it doesn't matter that it's dollars. It could be, and it becomes this in algebra in high school, could be x's, right? This is where the concept of like or similar terms comes into play. So if I translate this original question where it says simplify to words, what this is 5/8. What a weird word. Plus 7/8. Is that right?
I think so.
Doesn't that look weird to you? It does. Okay. So it's not just me. Now I got everybody worried about how to spell the word eighths. 5/8 plus 7/8 minus 3/8. Well, 5/8 plus 7/8 is 12/8 minus 3/8 is 9/8. So we get 9/8. Of course, this bit of business all up here is going on behind the scenes in your head. You're not actually writing it. What we do in math is we say that means we can take 5 plus 7 minus 3, quantity eighths. This is where that rule comes in from junior high and elementary school, where what you want to do is you want to bring the things together with a common denominator, and you rewrite the expression with that single denominator, and all of the numerators of all of the other fractions get put together. So this is 9/8. Are you with me on that? You cannot add things together unless they are the same kinds of things. It makes no sense to talk about adding kittens and donuts. If I had 10 kittens and 5 donuts, then I have 10 kittens and 5 donuts. I can't put those numbers together. On the other hand, if I take a look at this one, the reason why I cannot add, and you don't need to write this down, but the reason why I cannot add these things is they are different kinds of things. This is like me asking you to add 5 quesadillas, 7 cheeseburgers, and then take away 2 goldfish. I can't do anything mathematically with those numbers. I have 5 quesadillas, 7 cheeseburgers, and -2 goldfish, whatever that means. Maybe they're upside down, who knows, doesn't matter. So we need to make these into the same things. And this is where the concept of a common denominator comes in. If I can take this 5/4 and this 7/8 and this 2/3 and arrange it so the denominators are all the same, then I will be adding the same types of things and I can put them together. The question becomes, what is the common denominator? And some students in earlier grades, I know this because I talked to the grade 9 teachers, some students get into the habit of, I don't know where they pick it up, saying the common denominator will be the product of all of those numbers. And I'm going to write something down. I don't want you to write anything down here just yet. What some students will say is, well, a common denominator is something that I can convert all of these fractions to. And 4 times 8 is 32, times 3 is 96. So they go, well, I'm going to convert this to 96ths. Now, will this work? Yes. What's going to happen is you're going to get fractions that are bigger than they need to be, so 2 points to be made. If the fractions are bigger than they need to be, then the work is harder, and you might forget, second point, to simplify the result. The other point I want to make, though, is this. If you think this is the way to find the common denominator, what we call the lowest common denominator, and you do this with fractions like, say, this or this, it's not even that you'll have more work to do, you'll dig yourself an algebraic hole that you cannot get out of at this level. And I know there's going to be at least one question that's assigned today that almost everybody asks about the next day because they don't find the right lowest common denominator. They end up with something that's so big they can't recover. Okay? And even if you knew how to recover, you don't want to do all that work. So 96 is a common denominator here. That's true, but it's not the lowest. How many of you know what the lowest common denominator is? What is it? I think it's 24, yeah. By the way, if I go with the 96, this student would be saying, well, I'm going to multiply the top and the bottom of this by 8 and by 3. The top and the bottom of this by 4 and by 3. The top and bottom of this by 4 and by 8. And these would all be over 96, and then they would proceed, right? But 24 is the lowest common denominator. Now let me ask you a question, Sawyer. How did you figure out that that's the lowest common denominator? All of them go in there, so all of them divide into 24 without remainder. So you kind of saw it. But, you know, what if it were something like this? I think it's probably pretty obvious that nobody sees what the common denominator is. I don't. If you do, congratulations, but I don't. So how do we confirm that it's 24? And I'm not going slow here because I think you're incapable of understanding. I'm trying to build the foundation for something really important. What do we do whenever we're working with rational expressions? What's the first thing you always do? Factor. So I'm going to factor these denominators. This is 5 over 2 times 2 plus 7 over 2 times 2 times 2 minus 2 over 3. And I'm going to be focusing on the factors in the denominator. Finding out that it's 24 is pretty easy. But if the numbers are bigger, what do? You do this. You say the lowest common denominator has to be a number which contains all of the factors of the first denominator, period, and all of the factors of the second denominator, period. and all of the factors of the third denominator, period. So we look at each of them separately. The lowest common denominator has to contain 2 times 2, because the first denominator contains 2 2's. Period. You end there. You go on to the next stage. The lowest common denominator has to contain 3 2's, because the second denominator is 3 2's as factors. Well, that means we need another 2. And if you put 2 2's and then an additional 3 2's, you're going to end up with that number of 96. You're going to end up with that denominator that's way too big to make our jobs easier. So is the first denominator represented in our lowest common denominator? Yes. Is our second denominator represented in this denominator? Yes. There's an overlap there. And is our third denominator represented? Well, not yet. But it is now. And when you multiply 2 by 2 by 2 by 3, you get 24. That means we're going to put this over 24. We're going to put this over 24. We're going to put this over 24. And whether you're looking at the very top line here or you're looking at the middle line that has some highlights in it, the bottom line is I need to multiply the top and the bottom of this by 6. And I'm multiplying top and bottom by that number because then I'm multiplying by 6 over 6, which is 1. It's 6 because the bottom has to multiply out to give 24, and I already have 4. And that means on the top I get 30. Over here, I need to multiply top and bottom by 3 because this is 8. 8 times 3 is 24. So on the top I get 21. And here I need to multiply top and bottom by 8 to get the bottom to be 24. So I get minus 16. We okay with that? I mean, admittedly, by the time you get to Math 20-1, you should know how to add those fractions. But we're going to take the leap here in a minute from numerical fractions to algebraic ones. That means this becomes 30 plus 21 minus 16 all over 24. 21 minus 16 is 5. 30 plus 5 is 35. I'm pretty sure that's right, 35? Yeah. Over 24. Can I simplify 35 over 24 down? No, because I used the lowest common denominator. However, I shouldn't even have said that. No, even if you do use the lowest common denominator, it turns out that sometimes when you put these numerators together, you get something which can be reduced with the new denominator. Okay? Write a rule to add or subtract numerical fractions. Convert to an LCD. Add numerators. I'm not going to say or subtract. Obviously, if we're subtracting, we're going to be subtracting. Add the numerators. Denominator stays the same. And then, kind of like what we said when we were working with radicals, you always want to simplify. You always want to stop at the end and look at the finished product and say, can I simplify that a bit or at all? So these rules that we're using are the same as the rules we would use to add or subtract rational expressions. Well, let's get to it then. And I'm starting off with examples which are really, really simple. Why is this such a simple thing to simplify? Because the denominators are already common. All this is going to become is 3x plus 5x plus 6 all over 2y. We can add the numerators together now and get 8x plus 6 over 2y. Can I cancel anything? Yes, but only if I cancel properly, which means to factor and cancel. I don't want to just do something like this and just say, well, 8 over 2 is 4 over 1. I can't do that. What I need to do here is take a 2 out of the numerator, and then, well, let me back up here. You understand that as soon as we put these together and get here, we're talking about what we learned how to do on the first day of this unit, simplify a single rational expression. You do that by factoring and canceling. So now I have a factor of 2 in the numerator and a factor of 2 in the denominator. That means I get 4x plus 3 all over y. Incidentally, because y was in the denominator of pieces to begin with, y is not allowed to be 0. But in today's lesson, I don't care about non-permissible values. Don't worry about them. That's not the point. B. Well, again, we are graced with a very nice gift here that they're already over the same denominator, so we can go ahead and put them together. Now I can add the two numerators and get 5b minus 10 over b minus 2. Can I cancel anything? Well, I know you can, and I suspect many of you know you can, but the only way to be sure is to factor. So I can factor a 5 out of the numerator and be left with b minus 2, and we have a b minus 2 on the bottom, so the answer is 5. This thing simplifies to the number 5. Period. You know, there is a condition that b is not allowed to be 2, but I'm not worried about that today. We okay with b? Okay. Okay, well, p squared over p minus 4 minus 7p over p minus 4 plus 12 over p minus 4. Notice, when it was over 8, I was saying don't call it 7 over 8, call it 7/8. You don't need to call this p squared p minus 4s. Okay, it loses its meaning at that point. These are all over p minus 4. So I can write p squared minus 7p plus 12. And I think you can probably guess where this is going. That quadratic is factorable, and one of those factors, I believe, is going to be p minus 4. Cancel, you're left with p minus 3. There's non-permissible value of p equals 4, but who cares for today? All right, example 2. And I put here a note for example 2 that there are similar examples in your textbook if you want to take a look at them. You just turn the page, see if there's one more after this. Yeah, okay. I just want to look at my timing here. So what is the common denominator? Well, how many of you can tell me, how many of you feel as though you know what the lowest common denominator is? Colin?
5xy squared.
Not 5. Think about that number for a second.
Oh, sorry, 6.
Right. 6xy squared. And the reason is the lowest common denominator must contain all of these factors. So it has to contain a 2, an x, and a y. It also has to contain these factors. We don't have a 3 yet. We can put a 3 over here. There's no x's, we don't need to worry about that. And it has to contain y squared. So the 2xy is contained here, and the 3y squared is contained there. Again, there's that overlap. So we get 6xy squared. I made a little tactical error here. And that's that you should rewrite it first. The reason is, what you need to show on paper is the following. You need to show what you're multiplying the top and the bottom by to get to that new denominator. And if you try to squeeze it in up here, there's just not enough room. Do you get my drift here? So I want to change that 2xy to a 6xy squared. I need to multiply this by a 3, and I need to multiply it by a y, so I multiply the top and the bottom by 3y. I need to change the 3 to a 6 for the second denominator, which means I need to multiply by 2, and I also need an x. So I'll take a pause there. Are we okay with multiplying the top and the bottom by 3y for the first, and the top and the bottom for the second by 2x? The advice I would give you here is always go slow and methodically here. It's very easy to make mistakes. This is all going to be over 6xy squared. On the top we get 9xy, and then we get the product of the 2x and the 5x plus 6y. So that's going to be 10x squared plus 12xy I can put the 9xy and the 12xy together. Can I factor anything out of the top? I can factor an x out of the top. And I should, because I see there's a factor of x in the bottom. Just one final note before we go on. You understand you don't need to write the two x's in brackets. I'm just putting them in brackets to show you they are factors. So I end up, after the canceling, 21y plus 10x over 6y squared. You okay with that one? If you would have noticed, you could have simplified the first rational expression to begin with. 3x over xy squared, I could have just canceled those x's and done this. In which case, my lowest common denominator would only be 6y squared, and I would have arrived at my correct answer one step earlier. Let's try another one. Who wants to take a stab at what the lowest common denominator is? Colin, do you know?
B squared minus 9.
It is b squared minus 9. And many of us will look at that and go, well, why is it b squared minus 9? Because many of us don't remember to factor things first. You need to factor things. And one way or another, Colin, whether you factored b squared minus 9 or not, you knew b squared minus 9 was b plus 3b minus 3, right? So when you take a look at this, this is 3b over b plus 3, b minus 3, minus 2b minus 10 over b plus 3. So the lowest common denominator has to contain all of these factors in that denominator. And it has to contain all of the factors in that denominator, but it already does. This would be the equivalent of me saying something over 12 plus something over 2. The common denominator would be 12 because the 2 is already a factor of that common denominator of 12. That means we're going to have to multiply top and bottom by b minus 3. We put these together. And something has to be taught to you here, and it requires you to think carefully. I'm not going to multiply out the bottom. I'm not going to multiply out the bottom because I want to leave things in factored form in case there's a common factor that cancels. Does that make sense to you? Okay. Now look at the top. I am going to multiply out the top. Why am I going to multiply out the top? Because I want to get it into a simplified form so I can then factor it and see if there's a common factor that cancels. I can't look at this top mess right now and decide what's going to happen in terms of factors. It's not possible. So my next step is to simplify the top. And I will give everybody a minute to make sure that you're getting the same thing when you FOIL out the top. Wow, when you FOIL out the 2b minus 10 and the b minus 3. I'm pretty sure that's right. This is over b plus 3, b minus 3. I don't normally like to do this. I just don't want to have to rewrite the whole thing just so I can put that negative 6b and the negative 10b together. It's negative 16b. So the top becomes 3b minus 2b squared plus 16b minus 30. I'm subtracting everything. I'm subtracting this. I'm subtracting this. I'm subtracting that. All right? You can think of it as, yep.
Why is it 16b positive?
Because it's negative 16b in the brackets, but I'm subtracting negative 16b. How many of you were taught, let me explore this a bit more, 2, 16, 30. How many of you were taught that when you're subtracting a polynomial, you remove the brackets and change all of the signs? How many of you were taught that you can sneak a 1 in here and then take this negative 1 and multiply it through? You've probably seen both of those ideas. I just say I'm subtracting. When I subtract 2b squared, I get negative 2b squared. When I subtract negative 16b, I get positive 16b. When I subtract 30, I get negative 30. Does that answer your question, Zach? Okay. So now this is all on b plus 3, b minus 3. I mean, I think if it hasn't dawned on you yet, this is going to get pretty heavy. It's not just, it's maybe the more challenging part of algebra is working with rational expressions. I can simplify this by writing it as negative 2b squared plus 19b minus 30. Is it possible, I'm not asking whether it happens or not, is it possible that this new numerator is factorable? Maybe. Is it possible that if it is factorable, one of the factors will be b plus 3 or b minus 3? Maybe. So what I would recommend here is just do a little exploration. I've factored the negative out. It's not equal to 0, so I can't just get rid of the negatives by moving stuff to the other side. But the reason I factored the negative out is my brain, and yours as well, I'm assuming, cannot cope with trying to factor a quadratic that has a leading coefficient that's negative. Whereas this, my brain can cope with that possibility, right? So do you see, given the nature of the numbers, negative 19 and 30, why don't we find out the discriminant here? And if the discriminant is a perfect square, then we can proceed to factor it. If the discriminant is not a perfect square, then we are done. Then that last thing we wrote is the answer. Oh, it's a perfect square. I'm surprised. I really am. Well, these have to both be negative, don't they? Because they multiply to give a positive. 3 and 10? Negative 3 and negative 10. Put in the right places. Just a second here. I don't think it does. Negative 3 and 10?
15 and 2.
I think 15 and 2. And the 15 is going to be here, and the 2 is going to be there. Those of you that were like me and said 3 and 10, there was an issue there that one would have to be positive and one would have to be negative to make that middle term work. It's actually 15 and 2. I get 15, negative 15b on the inner, negative 4b on the outer. That's negative 19b. But here's the thing. If I put that, and I'll write it down. I don't want to skip a step here. If I put that here, does anything cancel? No. So you may not like this, but that means if you would have stopped here, this is correct. But you won't know if that's where you should stop until you try to factor it to see if something cancels. Catch my drift?